Hey guys, today we're going to do Chapter 4, Section 8, which is on translations of sine, cosine, and tangent functions. So on the last lesson we talked about scale changes that we could do, which changed our period and our amplitude of our functions. Today we're going to talk about translations, which actually change the phase shift and the vertical translation. So phase shift is the least positive or greatest negative magnitude of a horizontal translation that maps the pre-image sine wave onto the image sine wave. So basically a phase shift, what it does is it moves the function left and right, so it's changing our x values. So the first problem is we want to identify the phase shift from y equals sine of x to y equals sine of x plus 2 pi over 3. So if we think back to Chapter 3 where we were talking about doing scale changes and translations onto just normal types of functions, onto parent functions, well, this is the same exact thing. So if I were to write my translation here, I'm just going to change that to a t since it's a translation. Okay, in my function, I'm adding 2 pi over 3 to my x value. So that means that I do the opposite, so subtract 2 pi over 3 in my actual translation equation. So the phase shift in this case would be negative 2 pi over 3. Okay. Now, vertical translations, that's just a shift up or down, so that's changing your y value. So if we let f of x equal sine of x, we want to find the equation for g under the translation t of xy maps onto x comma y plus 2, which is a vertical translation of 2 units up. So if I do that, remember the first thing I do is I do the opposite of each of these things. So I'll have y minus 2 equals sine of x, and then I'll just move that over. So I'll get y equals sine of x plus 2. So it's really the same exact thing that we were doing in Chapter 3. The only difference is now we're doing it with sine and cosine functions. Alright, consider the graph of the function f of x equals cosine of x minus 9 pi over 4 minus 4. We want to find each of the following. So the first thing we're going to look for is the phase shift. Well, inside my function I'm subtracting 9 pi over 4. So that means that my actual phase shift is just going to be positive 9 pi over 4. Okay, my period, well, remember that the period only changes if you're multiplying your x values by something or dividing it by something. In this case, we're not multiplying or dividing our x values by anything, so the period's just going to remain the same of our parent function, which is the cosine function, which is 2 pi. Same thing with the amplitude. The amplitude only changes when you're multiplying your y values by something, so my amplitude's going to stay the same as my parent function, which is 1. Now my maximum and minimum values, those are going to be changing because as you can see here, what I'm doing is I'm shifting my graph 4 down. Now normally my cosine function goes from negative 1 up to positive 1, but in this case I'm shifting it 4 down, so if I go 4 down from negative 1, that's going to be negative 5, and if I go 4 down from 1, that's going to be negative 3. So I'm going from negative 3 for my maximum to negative 5 for my minimum. Alright, next up we've got a parent function here and we've got this graph, and what we want to do is write an equation for the translation image. So normally your cosine function, well, let's start with the cosine function. So normally my cosine function, I go from negative 1 to 1, I'm going here through the middle, and then it takes me 2 pi to get back to where I started. So your cosine function would look something like this, where this is pi and this is negative pi. So that's your parent function. Okay, in this case, you'll notice that my maximum here is at pi over 3 instead of being at 0. So that means what I've done is I've shifted to the right by pi over 3. So that gives me a phase shift of pi over 3. Now, as far as my vertical shift goes, remember that's saying how far you've moved up or down. Well, normally my function goes from -1 to 1. In this case, my function is going from 3 to 5. So that means that I've shifted the graph up by 4. And so I've moved my graph up by 4. So knowing that, if I have a phase shift of pi over 3 and a vertical shift of 4, my translation equation is going to be x plus pi over 3 and y plus 4. So to put that into my actual equation here, I'm going to do the opposite, x minus pi over 3 and y minus 4. And I'll have y minus 4 equals cosine of x minus pi over 3. And then I'll move my 4 over and I'll get y equals cosine of x minus pi over 3 plus 4. Okay, so that's going to be my new function. Now the sine function is just a little bit trickier. Remember that for your parent function for sine, we start at 0, 0. We still go up to 1 and down to -1, but in this case your function looks more like this. Okay, so that's your sine function. So we're looking for this point here and we're thinking about how that's changed. Well, this 4.5 here isn't in terms of radians, so I don't like to use that. In fact, I'm going to do something different. I'm just going to focus on this point here, my maximum. And then I know that the period hasn't changed because we haven't gotten into anything with doing both at the same time. We're just talking about translations right now. So I know that my period hasn't changed. My period should be 2 pi. So if I've shifted this over pi over 3, that means that this will be pi in the other direction. So if I think about it, pi over 3 minus pi, that means that this point here is at -2 pi over 3. Okay, and that looks like that's at 3. So that point is -2 pi over 3 comma 3. Now, if I'm going from -2 pi over 3 to pi over 3, that's what this wave is. I'm looking for this point that's halfway in between that. So halfway in between -2 pi over 3 and pi over 3, well, I know that that's going to be -pi over 3. No. It's going to be -pi over 6. Because this is actually just -4 pi over 6. This is 2 pi over 6. If I think about that distance, that's a distance of 6 pi. So if I add half of that, 3 pi onto here, 3 pi over 6, I'll get pi over 6, -pi over 6. So this point here is at -pi over 6. And that would be at 4. Okay? So because of that, I have a phase shift of -pi over 6. I have a vertical shift that stays the same as for my cosine function, which was 4. So my translation equation is going to be x minus pi over 6, y plus 4. If I do the opposite, x plus pi over 6 and y minus 4, and plug that in, I'll have y minus 4 equals sine of x plus pi over 6. Okay, and then I can add this 4 onto the other side, and I get y equals sine of x plus pi over 6 plus 4. Okay, so I did a lot of work to get this phase shift here. It's actually a lot easier than that because we have this theorem that tells us for all real numbers x, the cosine of x minus pi over 2 is equal to sine of x. So essentially all I had to do was take this phase shift here and add pi over or subtract pi over 2 from it to get this phase shift here. So if I think about it, if I take pi over 3, which was my original phase shift, and I subtract pi over 2, well, to find a common denominator here, I can have, this is going to be 2 pi over 6 minus 3 pi over 6. That gives me negative pi over 6, which gives me the phase shift that I had here. So all this work that I did over here to find this phase shift, if it didn't really make sense to you, that's okay, because we just have this theorem here that says all you have to do if I'm going from cosine to sine is subtract that pi over 2, and that's going to give you your new phase shift. And that is everything for section 8.